So, okay, so now let's take out our worksheets, write down Newton's force equations. Okay, let's look at the first one, a car hanging from a...
Well, seems like a Batman.
Probably like a steel rebar. String.
So imagine it's a string. What's that force called?
Tension.
Good. And tension always acts. Okay, so basically how many kinds of forces are there?
Like actual rate. Yeah.
What are they?
Push and pull.
You can either push with a force or you can pull with a force. Okay, when a force is applied through a string or a chain or anything, what is the only way you can apply a force? With a string. Can you push with a string?
You could try.
Okay, well, even if you did try, what would happen?
It's like playing pool with a rope. Like it's not.
Yeah, it's not going to happen, right? So exactly, it's like playing pool with a rope. It's not going to work. But if you have a rope or a string, what's the only way to apply a force with it? Pull. So when you pull something, you always pull away from the object. So what direction should this force be?
Upward.
Upward. And that force was called? And what is the one force, as long as we are on planet Earth, we know it exists?
Gravity.
Force of gravity. We cannot escape it. And force of gravity always does what? Pulls it. What direction? Notice the words you guys used. It always pulls it down. And it always acts on the center of mass, which is also called center of gravity. I usually don't say center of gravity just because center of mass is more general. Center of mass exists no matter where you are. Center of gravity only exists as long as you're on planet Earth, right? So I tend to think of it as center of mass, but people also call it center of gravity. Okay? So you guys have heard those words before. A center of gravity for a box is always in the center of the box, right? As symmetrical objects go, they're always to the center. Okay. Just so that we are all very clear on this, and that force is always called the object's weight. And usually people put W. I don't put W's because W in my head is always the work. So they're both using W, so I always put mg. So always, you'll see mg's. You'll know it's m times acceleration, which is always a force. Weight is a force, right? When you get on the spring scales, you're measuring your weight. You know, you're not measuring your mass. It gives you your mass, and also your weight is measured in good. It is never measured in kilograms. Your mass is measured in kilograms. When you stand on your scale, the scale reads and gives you pounds or kilograms, but it's actually measuring newtons, and then it converts it for you by dividing it by 9.8. Okay, anyway, so how do you write this equation? Sigma Fy equals T minus mg. People familiar with that? There are a couple of possibilities. When things accelerate, what happens to ma? So sigma F is defined as the sum of the forces, right? Sigma F is the sum of the forces, all the forces acting on it. So on this side, on my left side, what are the possibilities for sigma Y? Well, it could be 0, or it could be ma if I have a rectilinear motion or motion in a straight line, or it could be mv squared over r if I am moving in a circle. These are the three possibilities we have. Please remember that when things are moving with a constant speed or not moving at all, sigma F equals 0. If things are accelerating in a straight line, sigma F equals ma. If things are moving in a circle, sigma F equals mv squared over r. Good? So I'm going to erase this. In this case, is the box accelerating?
No.
So what do I do with sigma Fy? Put it to 0. So this implies I'm going to get 0 equals T minus mg or T equals mg. Tension has to equal mg.